Hello my dear students. Today I am going to help you in solving worksheet number 12. And today's topic is atomic number and mass number. So let us begin the discussion with MCQs. The first MCQ is, what is the mass of 1 mole of carbon atom? And carbon is carbon 12. You know, carbon is found in more than one isotopic forms. So this carbon is having carbon 12 atomic mass. So out of the given options, 1 mole of carbon has, as it is mentioned in this notation, that it has 12 grams mass in it. So this is very clear. MCQ number 2. What is the number of moles of hydrogen atoms in 3.2 gram of methane? Now, what is mole? Mole is the amount of substance, and it is one of the very important SI unit, System International Unit, for amount of substances. And we can find out the number of moles in the given grams. How? The given grams is divided by the molar mass or the molecular mass. Methane has the chemical formula CH4, and when we add the relative atomic masses of carbon, that is 12, in the mass of hydrogen, as 4 hydrogen atoms are there and each hydrogen atom is 1 gram, so 4 atoms will be contributing 4 grams. So when we add 12 plus 14, we get molecular mass of methane. So simply divide the number of the mass in grams divided by molecular mass to get the number of moles. Now you know that 1 molecule of methane has 4 atoms of hydrogen. So you have to multiply the number of moles found by number of atoms to get moles of hydrogen atoms. Now third MCQ is, the relative atomic mass of chlorine is 35.5. That is the relative atomic mass. And what is the mass of 2 moles of chlorine gas? Chlorine exists in diatomic molecular form, and 1 molecule of chlorine has 2 atoms of chlorine in it. So the mass will be doubled for 1 molecule. And where 2 moles of chlorine gases are given, so again this mass will be doubled. First 2 is representing number of atoms per molecule, and this 2 is representing number of moles of chlorine. So you can better calculate it. The next MCQ is, 18 gram of water contains the same number of molecules as. Now this is the hint of molar mass of water. When we know the molecular formula of water, that is H2O, and when we work out the molecular mass of water or the molar mass of water, that is 2 grams of hydrogen and 16 grams for oxygen. So we get 18 grams, means it is just 1 mole of water. And when it is observed in the given options that you are given 18 grams of ammonia gas. Ammonia means NH3. When you work out the molecular mass of ammonia, that's not equal to 18, that's 17. So A is the wrong option. When you see option C, 14 grams of nitrogen gas, again nitrogen is also a diatomic gas, molecular gas, in which 2 atoms of nitrogen are given. So one atom of nitrogen is 14 gram, and 2 atoms of nitrogen will not be 14, that will be 28 grams. So C is also not considered. Now when we see option D, that is 16 gram of oxygen gas, again oxygen gas is also diatomic. so it will be doubled. So D is also wrong. But when we see 2 grams of hydrogen gas, yes, that is the very true, because hydrogen also exists in diatomic molecular form, and 2 of the hydrogen gas atoms give us 2 grams in the mass. Now, fifth MCQ, which quantity is the same for 1 mole of ethanol and 1 mole of ethane? When we talk about mole, in fact, we count the number of particles, and you are given 2 compounds, means atoms will not be considered, only molecule number will be considered. 1 mole of every substance has a fixed amount of particles, and that is 6.02 into 10 raised to the power 23. This number is a constant and is called as Avogadro's number. Now we go ahead for the theory discussion. The very first is a very conceptual question which is asking you define relative atomic mass. The relative atomic mass, which is written as AR. The relative atomic mass of an atom is the average mass of one atom of that element compared to 1/12 of the mass of one carbon 12 atom. So, masses of all the atoms are in fact standardized by carbon 12th mass. So, this is how it is calculated and written in the periodic table. The next is compare a neutron and an electron, how they are different. First, you must be very confident in subatomic particles. You must be knowing the names and their properties. When you know that electron is a subatomic particle which is negatively ionized, and neutron is a particle which has no charge on it. The second difference is in their positions. The electrons do not stay or do not rest in the atom. They keeps on revolving because they have very high kinetic energy and very negligible mass. But neutron is the neutral particle, and it is the heaviest particle out of 3 subatomic particles: electron, proton and neutrons. So it stays in the nucleus. The last question is draw the structure of carbon atom and show the nucleon number. Okay, in this section you are asked to draw the structure of the carbon atom, means you must be drawing the nucleus and you must be drawing the orbits, and nucleon number is asked. You know, the nucleon number is the number of particles present in the nucleus, and there are 2 subatomic particles making up the nucleus. One is proton and the other is neutron. So from where you will be getting the data to write how many particles of protons and neutrons and electrons are present there? Just look in the periodic table. Carbon, at the carbons box, it is written carbon 12 and 6. So 6 is its number of proton, and for every neutral atom, number of protons are equal to the number of electrons, and this 12 is its nucleon number, means the particles proton and neutrons which are making up the nucleus. So number of protons are taken from the atomic number, and electrons are also taken from the atomic number, and neutrons are taken by subtracting 6 from 12, means atomic number is subtracted from the mass number. I am sure that I have explained it well. Now it is your turn to solve it, and just to memorize and apply all the concepts given in your chemistry course. And this worksheet will be a great help in summing up all the important points according to your exam patterns. Okay, I'm leaving you here with the hope that you will be putting your comments on the feedback, and I will be very welcoming to see them and to reply them. Thank you, class. May God bless you. Wish you a very happy new year and take care. Bye bye.